The 19th century was a time of big changes. People moved from farming to working in factories, and new machines made work faster and easier. This was called the Second Industrial Revolution. During this time, electricity, steel, and petroleum products were invented, which changed how things were made and how people lived. Science also made great progress. New ideas helped people understand the world better. Scientists learned more about atoms, elements, and energy. They also made important discoveries about light and radioactivity, which led to new technologies and inventions. In the late 19th century, physics made big discoveries that changed how people thought about matter and energy. These discoveries show that even the smallest parts of the matter are made of smaller parts, leading to new ways of thinking about the physical world.
Okay, so now let's talk about John Dalton. So John Dalton was an English chemist, physicist, and a meteorologist who made significant contribution to various fields of science. And one of that is the atomic theory. So this was proposed in 1803 and it was a groundbreaking concept that transformed our understanding of matter and the structure of atoms. So Dalton is best known for his development of the modern atomic theory, and he proposed that elements are composed of small, indivisible particles called atom, and that compounds are formed when atoms of different elements combine in whole number ratios. Okay, so here are some of the assumptions of Dalton's atomic theory. First is elements are composed of small indivisible particles called atoms. Second, all atoms of an element are identical in mass, size, and properties. Third, atoms of different elements differ in mass, size, and properties. Fourth, atoms of different elements combine in whole number ratios to form compounds. And last is chemical reaction involve the rearrangement of atoms. So in conclusion, Dalton's atomic theory laid the foundation for modern chemistry and paved the way for the discovery of the subatomic particles and the development of quantum mechanics.
Mendeleev, a Russian chemist, formulated the periodic table in 1869. He arranged elements by increasing atomic mass and grouped them based on similar chemical properties, creating vertical columns called groups and horizontal rows called periods. His periodic laws stated that the properties of elements are a periodic function of their atomic masses. Mendeleev's table was groundbreaking because he left gaps for undiscovered elements and accurately predicted their properties such as gallium, scandium, and germanium. These predictions were later confirmed, cementing his table's validity. He also corrected atomic weights of some known elements to fit his system. Although more modern periodic tables are based on atomic number rather than atomic mass, Mendeleev's work laid the foundation for understanding elemental relationships and periodicity in chemistry.
Okay, now let's talk about Hermann von Helmholtz, born on 1821 and died on 1894. He is a physician known for formulating the law of conservation of energy in 1847. He also made contributions to electrodynamics, thermodynamics, and physiological, inventing the ophthalmoscope in 1851. In the fields of psychology, Helmholtz is known for his mathematics concerning the eye, theories of vision, ideas on the visual perception of space, color vision research, the sensation of tone, perception of sound, and appraisement in the psychology of perception. And physics, he also known for his theories on the conservation of energy and on the electronic double layer, work in electrodynamics, chemical thermodynamics, and on mechanical foundation of thermodynamics. So that's all for Hermann von Helmholtz.
James Clerk Maxwell. He made a monumental contributions to the progression of science in the 19th century, particularly in the fields of electromagnetism, optics, and kinetic theory. In connection to Heinrich Hertz was a German physicist best known for his experimental confirmation of the existence of electromagnetic waves, which had been predicted by James Clerk Maxwell. Hertz's work proved Maxwell's theories were correct and opened the door to the development of modern radio and wireless communication. So Maxwell had theorized in 1860s that light and other forms of electromagnetic radiation such as radio waves were composed of waves and that these waves propagate through space at the speed of light. However, these ideas were purely theoretical until Heinrich Hertz came along.
Henry Becquerel made a groundbreaking discovery in 1896 when he identified radioactivity. So radioactivity is a phenomenon where unstable atomic nuclei spontaneously emit radiation. His work began while he was investigating the properties of fluorescent minerals in relation to X-rays, which had just been discovered. So when we say fluorescent minerals, these are minerals that glow under ultraviolet or UV light. Becquerel found that the uranium salts emitted rays that could expose photographic plates even in the absence of sunlight, indicating that these rays were a form of radiation. This discovery challenged existing notions about atomic structure, revealing that atoms could emit energy and transform into different elements. So for his remarkable contributions to science, Becquerel was awarded the Nobel Prize in Physics in 1903, which he shared with the Curies, marking a significant milestone in the fields of physics and chemistry. His legacy continues to influence modern subjects such as science, particularly in the study of nuclear physics and its applications.
So in 19th century, during that time, Marie Curie in 1867 to 1934 and Pierre Curie in 1859 to 1906 discovered the radium in 1898. In 1898, Marie Curie and her husband Pierre made a groundbreaking contribution to science with the discovery of two radioactive elements, the polonium and radium. They discovered first the polonium and after the radium. Their research began with the study of uranium rays, building upon Henry Becquerel's finding that uranium salts emitted mysterious radiation. Marie Curie hypothesized that this radiation was an atomic property of uranium itself, independent of its chemical or physical state. This insight led the Curies to investigate minerals like pitchblende, which exhibited higher radioactivity than pure uranium. Through meticulous experimentation, they conclude that these materials contain small quantities of unknown, highly radioactive elements. Their pioneering work not only expanded the periodic table but also introduced the concept of radioactivity, profoundly influencing the fields of physics and chemistry. Marie Curie's relentless dedication to science led her to become the first woman to win a Nobel Prize and remains the only person honored with Nobel Prizes in both physics and chemistry. So during that time, Marie Curie and her husband Pierre discovered the radium.
Joseph John Thomson discovered electrons in 1897 is a groundbreaking achievement that transformed the understanding of atomic structure through his experiments with cathode rays. So when we say cathode rays, these are electrons emitted by a heated filament in a certain electron tubes. So Thomson demonstrated that these rays were composed of negatively charged particles, which he initially referred to as corpuscles. So corpuscles is a medical term for a living cell, such as red blood cell. So his work revealed that these particles were much smaller than the atoms and had a significant charge to mass ratio, leading to the conclusion that they were fundamental components of matter. So in recognition of his contributions, Thomson was awarded the Nobel Prize in Physics in 1906. So his work not only established the electron as the first subatomic particle to be identified, but also laid the foundation for further discoveries in the field of atomic and particle physics.
In conclusion, the 19th century was a time of great change and discovery. It transformed how people work and live through new machines and inventions. Scientists made important discoveries and changed our understanding of the world. This breakthrough laid the groundwork for modern science and technology, shaping the world we live in today.